Hey class, it's Professor Nick Sinsky, UNC Charlotte, and this is a very brief demo I'm going to give you for part 3 of Project 1, which is the Pavilion intervention. What I'm asking you guys to do is to create a pavilion, which is just basically like a pretty box that people can walk through. Something like you get like the Venice Biennale or something like that. But this is a site for you to apply the parametric ideas that you figured out in the first part of the project. Okay, so applying your formal process to a pavilion composition, and the criteria for the pavilion are listed on Moodle. They're pretty basic. The site looks something like this. It's going to be a 40 by 80 bay. The pavilion form is a box. It can be either 20-20, so 20 foot by 20 foot, or it could be 20 foot by 40 foot. The height of the pavilion can be 1 to 3 stories. Each story is considered to be 12 feet. There's a wall around the outside of the pavilion, and it is supposed to be 8 foot tall. There must be at least a wall on one side of the pavilion site, and there can be a wall on all 4 sides of the pavilion site. The thickness of the pavilion is 6 inches. A wireframe here. The thickness of the wall is 8 inches. And this isn't like super critical, but it's just to kind of keep a consistency with things. The pavilion, has like a door opening. It's a standard size door opening. It may have windows, but only if they complement the parametric solution that you come up with. There's no stairs. There's no extra detailing. This thing it's just a scaffold. It's a dumb box for you to apply your parametric ideas to. It does not have to have the idea applied to it. You could think of it compositionally as doing something with the wall parametrically. You could think of some kind of ground effect, something like a canopy that somehow engages this whole thing, or somehow engages the front of the building. That's up to you. But the idea of this is that it's a composition. So the pieces that I give you are to be arranged with respect to each other and their proportions, and the intervention that you apply needs to take all those details into account, and it itself must adjust and negotiate to that pavilion site. The parametric expression needs to be sensitive to what's going on in the composition, and it should impact the composition. Okay, what I've done here is really very basic and really not very good. This is pretty much like borderline acceptable. But I just wanted to show you an example of just roughly what we might be talking about. So I've taken this form from the Shumi, and I've applied it as a wall and as a roof. The composition's pretty dull. It's centered. There's not a whole lot going on here. It's not really taking much advantage of the potential. It's just kind of wallpaper. All right. This would be what I would accept, but it's you're not really getting much out of it. So anyway, just want to give you an example of that. This has been baked, and so now it is actually Rhino geometry. You'll notice there's some craft problems with it. It overlaps here. It doesn't join this very well. You can use Rhinoceros to clean this up. I realize that in Grasshopper it's hard to do things very precisely, so feel free to make some adjustments to the Grasshopper geometry. Don't rely upon Rhino to fix your mistakes with Grasshopper, though. It's really better to do it right the first time. Really pay attention to how your piece adjusts parametrically, how it adapts to the site that you give it. So in this case, I'm adjusting to this wall size, and I'm adjusting to this roof size. Okay, these are actually different. They have to adjust to the different planes I'm using it in. So there's a bit of work that has to be done that you'll learn about in the second video that I posted. The craft on this is not great. It's actually just slabs laid out next to each other. This is better. It's all one piece, all one solid. Okay. But again, try to think of something integrated. Consider it a design composition, much like you would have had with Greg or with Michael Swisher, right? First year projects. Consider the whole. You can move the pavilion around to any location. You can change the angle of it if you would like to. The site itself needs to stay the same. The wall needs to be a wall, but the way that they relate to each other is really up to you. And if you wanted to break some rules, sometimes that happens in studio and in life. So that may be a possibility for you. Really briefly, extremely briefly, I want to just give you a quick refresher on Rhinoceros, particularly if you haven't ever used it, as some in our class might not have, just to give you an insight as to how you would even make a model like this in the first place. So to begin with, in Rhino, I'm going to go at the top view. And there's multiple ways to do this, but I'm just going to show you the way that I would model it. I would go ahead and start off with a rectangle tool, corner to corner. And the first corner I'm just going to put in 0, 0, just because. And I want the length, and I want to say 40 foot. And a height, 80 foot. And that gives me the basis for this thing. And you should really be sketching this and like plotting this and thinking about this before you get into Rhinoceros. You should have an idea of what sort of composition you're talking about based upon what you know how to do with your parametric form. So what I might do is, I might begin to like divide this out, into some quadrants. And what I'm doing is I'm snapping. I have midpoint snaps turned on, perpendicular snaps turned on. I'm using the line tool. I click to make a line, I right click to stop the line, and it's basically snapping as I go. Okay, so I've got a series of pieces made, so I have kind of a center point. The other thing I'm going to do is make my bounding box for my pavilion. I'm going to elect again a 20-20 pavilion, so 20 foot with the rectangle tool. And again, I'm just using a polyline, and I'm going to move this. And so, I might be able to situate myself there, or, in this quadrant, or here. And these are just kind of compositional exercises that I might play in order to situate that. Okay. The other thing I could do is I want to go ahead and offset some space for my wall, and when I do offset, I need a distance. I'm going to do 8 inches because I'm doing a wall. I'm going to go ahead and do a wall on 3 sides actually this time. So select a curve to offset. Now that curve is actually all one line. I don't really want that. I want to make it separate lines. So I can say explode. Let's do offset again. Okay, click, right click. No, actually I'm already set up. So single click. And if I right click again, I can start the command. Click, and then I offset. So I have to choose which side I want to offset on. I'm going to click inside, and that gives me the offset. And then click and offset. And that's going to give you the walls. Now that what that does is that kind of encroaches a bit on my pavilion wall. And that might be okay. Maybe I decide to build mine into the wall slightly. Or maybe I decide to offset it. I can go ahead and do that. Just move it away from the wall for now. And I'm going to go through a trim. And, oops, I want to do that. Right click and just click to trim. Okay. And I'm actually going to go ahead and delete this outer line now that I've got this. And I'm going to go and finish this off by adding some smaller lines here. And then I'm going to join these all together, JOI and join. And we know that this has to be 8 foot, so let's extrude it. We want to say cap yes, delete input yes, extrusion distance 8 foot. It gives me my wall. At this point, if I wanted to draw my surface, I could go in and I'm holding on the button, the mouse button, and I click on 2-point surface, and I could click in this corner and that corner, and that would give me a surface. I could also draw a rectangle and then activate a planar surface, which we'll see a little bit about parametrically in the second video. Okay, planar surface creates a surface from planar curves. Makes a lot of sense. Okay, so we have our basic site and our basic kind of low wall, and I'm going to go ahead and just hide some details here. Clean up these lines. Okay, hide this. Okay, so our pavilion is made up of, you know, this. It's basically this cube, and we can model it in a few different ways. The way that I'm going to do it is I'm going to go ahead again and offset it 6 inches. Actually, I need to explode that again. Made the same mistake. Okay, explode, offset. And I'm doing this because it allows me to choose some directionality with this. It is so here. I'm going to choose to do something. Okay, so I think what I'm going to do is make this my opening and make the sides my point of intervention, just for this piece. I want to get some grain going with this side and the intervention on this side. And again, this is going to be kind of lame, but it does give you an idea of how this works. So what I could do something similar to what I did the last one, where I kind of trimmed and joined these, and I could create 3 walls and extrude them. And then this wall, I could snap to with the technique I'm going to show you in the second video, and use that to create my parametric intervention. Another thing I could do is just take rectangles and basically you know, draw them. So I could say, I want to make this 24 foot tall. It's a 2-story. No, 36-story. 36. Alright. And I'm going to do another one on this side. And I can actually, if I snap to this, I don't even have to type in the 36. I can graphically sort of finish that wall. And again, this is not like great craft, but it kind of does the job. Okay. Then the last piece I would probably do is I'm going to draw one of these, and I'm going to extrude it. I'm going to set the last thing to be height of -6 inches, and that gives me kind of a cap for a roof. Not great craft because you can see the seams and everything in it. It's not what I would like to do, but it does the job for the time being. So we'll leave it at that. It'll look fine if you rendered it. For the most part, it's not going to look great if you try to do a 2D. You have to do some cleanup. It's not going to 3D print, but as long as we understand that, it's alright. So there, I'm starting to see my composition. And the last thing I want to do, you know, I might integrate my opening, my door, into my parametric surface. That's a possibility. The other thing I could do is to put the door on the side, because you have to have a door. And to do that, what I'm going to do is I'm actually just going to make a box that is, let's say, 36 inches. I already messed that up. Let's see here. Other corner, base, or length. Length, let's just say 10 foot. And the width is going to be 3 foot for 36 inches. And the height is going to be 72 inches. Well, 78 inches. Think about a standard, maybe a standard door, right? Okay. Then we could go through. I'm going to hide this. And I already kind of put this here. I actually don't like that, so I'm going to move it another module over. Okay. What I'm doing is I make this solid so that I can boolean it out of this door. So I just essentially, out of this wall, I made this essentially an extruded door. And I'm going to use that to trim away this form. This is a fine use of booleans. I'm usually down on them, but this is like very simple, and it's guaranteed to work. And the result is fine. So I'm going to go ahead and do boolean difference. Choose my first form, so, press enter. Choose my second form, press enter, and it opens up my door. Okay. So this gives me my basic Pavilion structure that I'm going to be manipulating with this piece here. And it's a little dull, but with the right parametric expression, it might be very interesting. You know, I think compositionally it could be maybe a little bit better, but we'll see. So what you could do with this is you could click, you know, this endpoint and that endpoint, and click this point and that point, and basically use that with the technique I showed you in the second video to reference that form. Something else you could do would be to do another one of these rectangular surfaces, and then actually just drop. If you go front view, no, back view. Let's see here, where's that view? Back. Nope, that's not right. Go to front view, and I could actually just drop a rectangular surface if this snaps right. It might not like that endpoint. Let's see here. Maybe I can do it here to here. Yeah, it's not gonna like that. Okay. Well, one quick way I can do it. That's kind of messy, but it would be to make a box. For some reason it's not snapping. Right. Let's see here. I need to snap to this corner here. Okay, I can just split these. That could be the... I got the order wrong. Okay, so we'll just click this one, split, click the second one. There we go. Okay, so click this one, split. Okay, kind of hacky, but does the job. Okay, so then I can go in to front view and just drop a surface across the face of that guy. So now I have a surface, and I can do things like divide surface and like reference that surface. So that's one way to make that happen. Don't forget, I don't want to like neglect the depth of this. When I'm thinking about the last phase of it, making it a solid, I need to look at that 6-inch depth, or at least some depth. It can't just be a surface. Okay, it has to really engage this piece. Okay. So, went through that pretty quickly, but I think that gives you some idea of the process for just modeling a simple Pavilion space. And now you have an idea of what I'm envisioning, you know, for this. Don't forget, you can have different proportions for this. It could be 2-story, 1-story. It could be a 40 by 20. There's lots of options for this, alright? But think really hard about how you want to make your gesture with your parametric precedent. and you know, don't phone this in. Like, this is an opportunity here. This isn't just about like how to get this stuff to like stick, but thinking about the opportunities that you can create with this. Like, what's the right thing to do with this project? All right, I'd like to see that. Okay, I'll talk to you guys soon.